All right, guys, so what we're going to be talking about here is we're going to be building off of what we talked about yesterday. So be aware that if you have not watched, usually you can kind of watch these videos, not necessarily out of order, but of all of the videos we have, this is the one that more than anything else, you have to have watched the video from rates of change in tangent lines because we build off of that. This is almost like part 2 of that lesson. So if you don't, again, if you haven't watched that, go back and watch that now, then come on back and watch this video. If you have watched that, which I'm imagining most of you have, or you were in class, one of the two, then you remember that yesterday what we talked about was okay, we're looking to find the slope of the tangent line. We talked about how important it was. And at the very end of what we were talking about yesterday, we said we actually have this formula that if we want to, we can take that formula and we can use that. It's just a simplified version of y2 minus y1 over x2 minus x1 when we're trying to find the slope of the tangent line. So in this case, if I were to do that, what I would have is 2 plus h squared minus 3 minus 1 is what we would get for f of x, or f of 2, excuse me, divided by h. And I'm going through this quickly because you can pause the video if you want on your own and find out what this is. This is still the limit as h approaches 0. And so when we do this problem, what we would find that the answer to this, our slope, would be 4. After we multiplied this out, so we multiply that out, combine like terms, cancel the h's, everything we talked about yesterday, we would do all that, and we would find out that the slope here is 4, the slope of the tangent line drawn at x equals 2. If we had the same function, and we wanted to do the same thing, you'll notice we would get like 1 plus h squared, h squared minus 3 minus, if I plug 1 in, I get negative 2, so I'd minus negative 2, all divided by h. And if I were to try and find that limit as h approaches 0, again, what we would do is we would multiply this out, combine like terms, cancel everything out, cross out the h's, and we would find out that that slope, again, if you want to work it out and find out what it is, just pause the video right now and work it out. But we would find out that that slope is equal to 2. Now, what I want to point out is not that you can do that and get the correct answer, although that is very important. What instead I want you to notice is there were a couple of things that were very, very similar both times we were finding those slopes. The first thing is we used this formula both times and we inserted the x value right there. So we inserted the x value and then we found out what the y value was when x equaled that particular thing. And it was exactly the same in both instances. Although we had different numbers, the process was the same. The other thing that was the same in both cases is we multiplied it out, everything canceled, in both cases, excuse me, and we were able to factor an h out, cancel it out, plug the h in, and find out what that slope was in both instances. And so one thing that's actually pretty important when it comes to calculus is knowing that when we look at these problems, when we look at these functions, we're going to be analyzing a particular function an awful lot. In other words, we're going to be trying to find the slope of a tangent, let me try that again. We're going to try and find the slope of a tangent line of a particular function at a bunch of different x values. It's never just one x value, it's a bunch of different x values, and we will talk about why later in the class. So the question then becomes, is there any specific reason why we had to substitute in 2 and 1 before we found the slope? And the answer to that question is, well, kind of. Like, there is a specific reason for those particular instances to find the slope, but because the process was exactly the same, what we can do instead is we can wait until we get to the very end of whatever it is we're doing, this definition right here, this limit is h approaches 0 of f of x plus h minus f of x to all divided by h. What we can do instead of plugging the x values in to start is we can wait until the very end and then plug in an x value. And I know that doesn't make a ton of sense right now, but just kind of stick with me here and understand that what we're doing is we are holding off plugging in any particular x values until we're ready. And what this will give us, and again, you can't necessarily see it right now, but what this will give us is it will give us a formula that will allow us very easily to find the slope of the tangent line at any given x value. for this particular function instead of having to do this the long way over and over and over again. Now, in order to do that, we are going to apply this formula. We're just going to apply it a bit more literally than we did before, because we're not going to put any number in for x, realizing that that x just represents whatever x value it is that we are going to try and find the slope of the tangent line at. So if I have f of x plus h, the way that I would find out what that equals is I would say, okay, wherever there is an x value, I just replace that with x plus h. And I know a lot of people struggle with the fact that I'm replacing an x with something else that has an x in it. But that's just, remember, we talked about this before with functions, or you should have talked about it extensively. It doesn't matter what's in the parentheses, you just do what it's telling you to do. So in this case, f of x plus h is equal to x plus h squared minus 3. Then f of x is simply, that's just another name for y. So up here we have our f of x. So f of x equals x squared minus 3. Now you'll notice our formula says that I just need to do f of x plus h. So I get x plus h squared minus 3 minus f of x. So I get minus x squared minus 3 all divided by h. Okay, so I get all of that. That's, if I were to do the limit as h approaches 0 here, that would give me my slope of my tangent line in general, how I would find that. Okay, now I will tell you, even though there are x's here, right now if I were to put 0 in for h, I would still get the indeterminate form. That does not change. What I'm going to do instead is I'm going to actually multiply this out just like we did if x were a number. It's going to look a little bit worse, and the reason for that is I don't have numbers here, so it's going to look a little bit different, but I've got x plus h times x plus h is x squared plus 2 times x times h, because each time I multiply an x and an h together, I just get xh. So there are 2 of them there, plus h squared minus 3. So that is my f of x plus h. I have found that now. Then you'll notice that I've also got x squared minus 3, but it's being subtracted. So I have to distribute the x squared minus 3 into both of those. So I get minus x squared plus 3. And then it's all over h. Now, when we did these problems when we had x values, what would happen at this point is all of the constant terms would disappear. When we do it while we still include the x, what should happen if you do this correctly is it's not just the constant terms that will disappear, but all of anything that doesn't, any term that does not have an h in it will also disappear. So I've got x squared here, negative x squared here, those cancel. Negative 3 plus positive 3 is 0, those cancel. So what I'm left with is 2xh plus h squared, which looks very similar to what we had before when we were looking at these problems, in that I can factor an h out of both terms on the top that are left over. And then that h will cancel on the top and the bottom. And this is still the limit as h approaches 0 of 2x plus h. So I take the 0 and I only put it in for h because that is the limit as h approaches 0, not as x approaches 0. Those are 2 different variables in this problem. I only put the 0 in for h. So 2x plus 0 is just 2x. So what we have found right here, and then we'll use it in just a second, but what we have found right here, what we have found, geez, let me see if I can get this right. Sorry, having technical issues. Okay, what we have found right here with 2x is this is a formula for this particular function that if we want to know what the slope of the tangent line is at any given number, I can just take that x value and I can plug it in. And I'll show you how that works in just a second, okay? But what we just found is what is known as the derivative. The derivative is simply a formula that once we find it, it allows us for that particular function to find the slope of a tangent line at any given x value where I no longer have to apply that same formula over and over and over again. So it's kind of a big deal, the derivative, because this formula makes analyzing particular functions much, much, much easier. Now, because 2 different people, more or less, invented derivatives at the same time, unfortunately, there's different ways to say that we need to find the derivative. One way we know that we're looking at the derivative is this right here, where it looks like f, and then there's like a tick mark. It kind of looks like an exponent of x. The way that we say that is not f tick mark of x, it's f prime of x. That little tick mark again. I don't know why they decided to call it prime, but that's what they use. So this one right here is also saying, hey, I want you to find the derivative. We say that is y prime. And though that was one type of notation. Now this other type of notation we have, it looks like it says dy divided by dx. And as we get further into the class, we'll talk about what that means. But right now, just kind of trust me that that is another name for the derivative. But we don't say dy divided by dx. Instead, we just say dy dx because nobody wants to say divided because it's three syllables, I guess. I don't know. So dy dx is how we say that one. And then this last one we see every once in a while if we are being asked to take the derivative of something that is not an equation, it's just a statement. And you'll see that as you work forward in this class. The way that we say that one is d dx. Just like we said dy dx without the divide sign, we say d dx without saying divided. Okay? So all of those are different ways to say the following. So if I had something like this, this says find f prime of x if f of x equals 3x squared minus 2x plus 1. What this is saying is let's find the equation of that, find the equation that will help us find the slope of the tangent line just in general. The way that we do that is we're going to apply the same formula that we looked at before, and it's always the same formula. The limit as h approaches 0 of f of x plus h minus f of x all divided by h. And the way that we find f of x plus h is we go 3x plus h squared minus 2 times x plus h. Again, that's f of x plus h. We just, everywhere we see an x, we replace it with x plus h plus 1 minus, and then we've got f of x, which in this case, I'm trying to get to erase. Come on, it erases all the time when I don't want it to. Oh, come on. Nope, that's not it. Oh, Parker. Technical difficulties. Anyway, there we go. Now it comes up. Okay, so I'm going to erase that. And we're going to go f of x is just 3x squared minus 2x plus 1. Again, I apologize for that. All over h. Now, there's more arithmetic to do here and more algebra to do than there was before. So what we do here is, again, x plus h is x squared plus 2xh plus h squared. But there's a 3 on the outside, so that I have to distribute that 3 into everything in there. So I get 3x squared plus 6xh plus 3h squared. And then I have to I have to distribute this negative 2 into both of those. So I get minus 2x minus 2h plus 1. Then this negative needs to be distributed to all of these, all 3 of them. So I distribute that and I get negative 3x squared plus 2x minus 1. And then that's all over h. Now that looks bad, but when we start seeing everything that's going to cancel, it actually makes it quite a bit easier. The 3x squareds cancel out. The 2x's cancel out. The plus 1's cancel out. And all I'm left with is this 6xh plus 3h squared on the top. And I can factor an h out of that. So I get 6x plus, oh, I'm missing something. Oh, there's a minus 2h here as well. I almost forgot that. So I got 6x plus 3h squared minus 2, if I factor that h out of that as well, all over h. Those h's cancel. And then, again, this is the limit as h approaches 0. So I take 0 and I only plug it in for h, and what I have is 6x minus 2. That is our derivative. Our derivative, again, is what we use to find the slope of the tangent line. So if I see something, we're going to skip that one. If I see something like this, where it says find f prime of 1, what that's saying is take that derivative that we just found on this problem, so I've got 6x minus 2, and find out what the slope of the tangent line is when x equals 1. That's what this is saying. It's just a fancy way of saying that. Well, all that's telling us to do is take 1 and plug that into my derivative. So I get 6 times 1 minus 2, which gives me 4. That is a way easier way, now that I have the derivative, to find out what the slope of the tangent line is when x equals 1. If I wanted to find the slope of the tangent line when x equals 0, I would just take 0 and plug that into my derivative formula, and I would get negative 2. Notice again how much easier that is. The first step was harder, finding the derivative. But once we have it, it's really easy for us to look and find the slope of the tangent line at any given x value much, much, much quicker, okay? And if I was looking at a graph, all that would mean is at x equals 1, if I were to draw a tangent line, like this one, oops, that was really bad, that was not a tangent line at all, but the slope of that tangent line would equal 4. And the same thing would be true at 0. If I were to draw a tangent line at 0, oh, that one looks much better, I would know that the slope of that tangent line is equal to -2 based on the fact that I have this equation that will allow us to find the slope of the tangent line. Now you'll notice I did skip another problem, and it's just in the interest of time. If I did this one, the only reason why I skipped it is when I have x plus h to the third, that just takes a really long time to carry out. You have to go x plus h times x plus h times x plus h. It's not that we can't do it, just in the interest of time with this video, it would take us a little too long. If you want to know what the derivative of that is, if you want to work that out on the guided notes and find out what the derivative is, you should get 3x squared minus 3 once you do all of the work for that derivative. Okay, and again, that will tell us the slope of the tangent line anywhere that I'm looking at this function, at any x value. So hopefully that makes sense. Again, this ties in with what we talked about yesterday. So you put the two together, and hopefully you understand now where the derivative comes from. Again, if you have any questions, please come in, and I will answer any question that you have.